Okay, now let's us continue. We continue with discussion about the overall the whole coding in this accurate simple deep learning from scratch.m. Okay, again we already discussed about the architecture, which is that is the most important things that we have to know. The rest is just the complement where in order for you to show that whether your architecture is working or not. Okay, we start with the first cell there, or the first section. Okay, we design the code. Okay, the code have been designed. This is the I can consider as one of the modern way to design code, where you can write by section or by cell. In Python they call it cell, in Matlab they call it section. Okay, you can write, you can execute the code by section. So that's why that is the purpose of double percent over here, because double percent there will show this is one section, this is another section. I think in Python also they have a, you need to put double percent and hashtag, I think hashtag. Okay, hash symbol, I'm sorry, double percent and hash symbol like this. Okay, that will show one cell or one section in Python, but in Matlab is double percent. So if you want to run this section only, then you just click the run section. If you will click the run, then it will run the whole M files there. So in order for you to know a step-by-step process, then that's why we need to run by section. Okay, so the first part, okay, this one is just we calling the data set. Okay, the data set which is this one. We are using the digit data set. So this is the directory. So you don't have to write the long directory like this, because now because this one is in your current directory here, so you just can write the name. But I always practice to write the whole directory like this, because let's say this data set is not belong to this current directory, it might be in different location inside your hard disk. So then you need to write the whole directories that refer to this. Okay, and for classifications, again for classification, in order for you to, if you can see that to prepare the data to for classification, then you need to put all the image inside this folder. If I double click this folder, okay, you can see that this is the classes from 0 to 9. So each classes here, you need to give the name of the folder which is similar to the name of the classes. So if I double click 0 there, you can see that inside the 0 folder you have a lot of pictures of a lot of image that represent the handwritten of 0. Okay, so in order for you to do classification that in Matlab, then you need to prepare that kind of arrangement, meaning that you need to put it inside one folder, and then you need to classify all the image into one classes, and then make it as one folder, and the folder name must be similar to the class name. Okay, so that is how we need to arrange, because that is how later you will see that is the standard arrangement for Matlab. Later you will see that we need to use that arrangement to make the Matlab identify which image does that what image that which classes does that image belong. So that's why you need to separate into classes and make it a subfolder where that subfolder name is same as your class name. Okay, so that's why you need to have this kind of arrangement. Okay, from 0 to 9. Okay, seems like your assignment, because we have face mask and non-face mask. So that's why we have two subfolder, face mask and non-face mask, and make your image put your image inside that folder. Okay, according to the class there. Okay, so the first cell is just to call that uh, the purpose of this one, we want to load the data set, meaning that I save my directory inside this digit data part, digit data set parts, and then I'm using this function or this uh, the built-in function in Matlab called image data store. Okay, image data store, we have another one which is called data store, and this is image data store. Data store is if you want to manage the data which is non-image data, and if you have a data set or data which is an image, then you need to use an image data store. Okay, so why Matlab have introduced to you with this image data store or data store? Okay, before we have an era, before we don't have era of big data and so on, most of the data have been stored or have been saved in one matrix. Okay, in one variable matrix. Because of the era of big data, because the data is too big, then it is not practical to store the data inside single metric or single variable. So that's why because the matrix or the matrix that can be hold by one variables in Matlab have a limitation in terms of size. So and another reason is because it will make your program become more and more slow, because you need a memory or RAM which is bigger to hold the big data. So that's why Matlab have adjust the way of managing the data by introduced with some properties or some features like data store and image data store, where actually image data store, okay, when this is actually you want to create one variables, the name of variable is imds, and that imds, the type of this imds, the variable type of this imds is called image data store. Okay, image data store is actually a type of variable. Okay, remember, if you talk about the primitive type of variable, is like integer, string, what else, float, logic. That is a primitive type of variable. So image data store is a non-primitive and is a customized and designed for Matlab only, meaning that Matlab have their own library, and we can see normally Matlab does not call it library, it's a toolbox, where actually there's a one variable type called image data store. If you want to create a variable with the type of image data store, then you need to do this. Okay, this one is just a name of variable. You can name other name as well, but because we need to create this as a meaningful information, so that's why a meaningful name, so that's why we use the word imds that refer to variables that the type of this variable is image data store, which will represent or hold the information about the data set inside this digit data set. Okay, so just this is how you want to create the image imds, where image imds will hold all information about digit data set. And then this is the directory, okay, directory of this one. And then if you can see the setting here, okay, we in the setting we also include subfolder true. Okay, you must include the subfolder inside this folder, which is 0 to 9. And then please make the label source as a folder name, meaning that once you execute this one, imds will store two things. One is the directory of the location of each image inside this folder, and each directory will label as their classes, and their classes is according to the subfolder name. That's why we need to set a subfolder label source equal to folder name, meaning that it will follow the classes name will follow the subfolder name. Okay, just we try to execute this. You will see. Okay, now we try to execute this section only. Run section. Okay, as you can see that this is the variables. Okay, we call that the variable name is imds. As you can see, the class name there is image data store. Okay, that is the class name. Okay, again, if you just type x equal to 0, for example, that is the variable name is x, and then the class name is double. Okay, because this is one value, you don't see the double. Let's make example x equal to 0s of 100. Okay, you can see that if you now you have x where the variable name is x and the type is double, but this one, the variable name is imds, the type is image data store. So it's a special non-primitive variable type that for the purpose of this is to hold that big data that related to image. So if I double click this one, okay, this is the imds. As you can see, this is why I call it a non-primitive data type, because if you talk about primitive data type like integer, string, or float, that type of variables only can store single value or single numbers. Okay, means that if you talk about integers, x equal to 5, so you can just you can just save one variables for that single variables. But when we talk about non-primitive data set, okay, you can see that one variable imds, actually inside this imds have their member variables. This is called as a member variables. Okay, I use the word that member variables because if you learn C programming or C++, they use that term, but in Matlab they use as a property of that. Actually, properties is also same as member variables if you talk about C++. Okay, so imds have a member variables 1, 2, 3, 4, 5. If you can see, this is the one that save the directory of each image location inside this digit data set. If you double click, okay, you can see that this is the directory. So d slash something something. So we have how many is there? We have up to 10,000 data set. Okay, this is because this DG data set, each classes have 1,000 image. So you have 10 classes. So that's why we have 10,000 image location there. So the one that save the location of image is this one. And then let's go to label. Okay, as you can see, the label here is labeled according to these directories. Okay, if directory is number 1, the class is 0. Directory number 2, image, the class is 0. So it will label according to that. You have from 0, 1, 2, 3 up until 9. Okay, so then that's why I ask you to arrange in that arrangement, because in terms of if you talk about the folder, because once you use the image data store, it will automatically label for you, so you don't have to waste your time, to make a table. We have a directory, a set of directory or location of an image, and then you have to label one by one by using Excel and so on, because image data store will do that for you. So you just execute image data store, then the image data store label for you. That's why you need to arrange and make sure that your image, which is belong to the same classes under the same folder, and the subfolder name the name must similar with the name of the classes. Okay, so okay, later we will discuss about the IMDS again. So now we execute the second section there. Okay, the second section is nothing, it's just for display of some of the image that inside this digit data set folder. We just put a random number of 20 image. Yep, we just calling some random number of 20 image from this one, and then we just do some looping to display this 20 image inside the same window. So that's why using a subplot there. As you can see that in order for you to display each image inside this image IMDS, you can just write show imds dot file. Why dot file? Because again, you can see IMDS, the directory is saved in this member variable called files. So that's why you need to put imds.files, and then you must give the index that you want. If you give the index 1, then it will give you this directory. You give the index there 10, then you get this directory location, okay, of your image. So let me extend here to show you actually it's an image. Okay, you can see that it's an image. Okay, so this one is just we just randomly collect 20 from this digit dataset folder and try to display. So if I execute this section, you just see the sample of image inside this digit dataset. Okay, so this is the what the IMS should do. Okay, that's why we need to repeat 120 times, because it will show this one first iteration 1, second iteration 2, 3, 4, 5 up until 20. So just display, just to showing the sample image inside that one. Okay, this is, even if you don't run this code, it's not important at all, it's just for display purpose. Okay, the important is that you need to the first section where you need to download upload your assigned your dataset with this IMDS. Okay, for you to easy to manage your data. And then the third section, again, this one is also not so important, just want to show you the description of data inside this IMDS or inside this digit dataset. If you run this section, it will display at this common window. Okay, you can see that, just showing you that we have 10 classes from 0, 1, 2 up until 9, and each classes you have 1000 image. So the purpose of this one is you want to count how, or to give you information about your data set. Okay, now we go to the next section. This is also not so important. This one is just give you another way to display image inside this one. Okay, again, like I said, you can also use this in this way. I'm sure, and you give you the file. Another way you can do is that by using this approach where you read first, IMDS, and then you give the index number 8, means that this one. Okay, even for this approach, you can see that the difference between this one and this one, even this one you don't mention imds.file, because this read image is a customized version that know that when you give your IMDS, it will search at the file. Okay, even you don't mention file, actually it search at the file and the index number 8. It will read the image, and then this one is to show the size. This one is one you want to show the image number 8. Okay, if I run this one, then you can see the size there, 28 times 28 here, because of this instruction. And then this is the image you using IMShow to show, which is the image for index number 8 inside this IMDS. Okay, so okay, this one is the most important one, as you can see, because the image is only single data set. So that's why you need to split it into actually it's not 2, it should be 3, but because this is the Matlab example, later we discuss it later, because I also not agree when Matlab try to separate this data into only training image and validation image. It should be actually 3. One is training image, the other one is validation image, the other one is testing image. Okay, because the validation and training will be used for training purpose, and the testing the test image will be used for the testing purpose. But let's proceed with this first. Okay, as you can see, you can use this function called split each label to split your data set into training and validation. Okay, this is just the name. You can name whatever you want. Okay, just remember that this function, if you use this function, the input is IMDS, and then you can set the number of training. If you select the number of training is any numbers, and the remaining numbers, it will become the validation data set. The one that you select here will become training data. So this one is number of sample per classes. So you remember that our number of sample per classes is 1000. So that's why 750 will be used for training data, while your the remaining is will be used for validation data. So what is the remaining data that left? It should be 250. So 250 will be used for validation data, and remember, it's not 250, you must time 10 because of the 10 classes. So 750 time 10, so the total of training data set is 7,500 sample, while the validation is 150 time 10 classes. It should be 1,500 sample. Okay, so this one is just show you it will behave, it will randomly selected among this image inside this data set. Okay, so this one you need to execute that. So let's execute. Of course, if you after you execute, nothing happen, because you can see that you already separate your IMDS into these two. Okay, as you can see, only the variable names different, but the type is the same, because it's just a split from here. From here you split into two. This one is 7,500, and this one is 2,500. I'm sorry, 2,500. So you can check it by double click there, and then you click the files, so you can see the total is 7,500. Okay, then this is your architectures. We already discussed this one. Let's execute this one. Okay, this one is just a building architecture. We don't do any training yet. Okay, we just set up some we just do manage our data set first, and then we design, or we define our architecture here. Okay, we execute this one. So execute this section. So we call it as a layers. So you will get one variable here called layers. Okay, this is the CNN architecture that you define here. Okay, once you finish that, okay, again this one is not important for you to execute, but if you execute, you just want to display the layers, or to check the layer, you can use this one. It's like the purpose is like I am show in image. Okay, image, if you want to display the image, you use I am show. If you want to show the architecture of your designed architecture, you can use analyze network. Okay, it's for display purpose only. So you can run this section, see what happened. Okay, so this is the network analyzer, that analyze network function, that once you apply that analyze network, then it will display the architectures, the designer architecture yet you define in the previous section. Okay, you can check there. This one is for the purpose of check, because if there's some weird things in the architecture, it will give you some warning or errors there, meaning that there's an error in your architecture arrangement. So if there's no zero warning and zero error, then you don't have to worry about it. Okay, you just can check the architecture one by one, which is this one is a convolution number 1, batch normalization, ReLU, and then go up into the last one. Okay, it also give you some the involved weak and bias there. Okay, so next section. Okay, this one is still not training yet, but this one is for the purpose of give some setting on your training mechanism. Okay, you need to set the option. So option is equal your equal to training option, you need to set a training option. In this example, we are using a stochastic gradient descent. Okay, even the name is a stochastic gradient descent. I think in the previous in the earlier lecture we discussed about stochastic gradient descent. When we talk about this stochastic gradient descent, is means that the W will updated for each and every samples, meaning each and every sample when you find and when you execute the forward pass and backward pass, and then you update the W. Okay, it's different from the batch gradient descent, where you need to get the mean error of the whole samples. Then that mean error will be used as the updater. So means that you will update one epoch. One you will update after you complete a full cycle, or one epoch per updater. But if you talk about stochastic gradient descent, one epoch will update with how many number of sample that you have. Let's say you have 10,000 sample, means that one epoch will update 10,000 times. So, but I just want to highlight here is that in this function is not stochastic gradient descent. Okay, even they just label it as stochastic gradient descent. Yes, it's a stochastic gradient descent. It's more to mini batch gradient descent. Okay, in Matlab, this function SGDM is referred to mini batch gradient descent, which is in between stochastic gradient descent and batch gradient descent, because as you can see that, okay, we don't because we don't mention the mini batch size there. Actually, inside this component you can set your mini batch size, but if you don't set the mini batch size in your option, by default Matlab will use a mini batch size equal to 1 to 8, meaning that it will, from the training data, say how many training samples inside our training data. Currently it should be 7,500. So 7,500 we divided into small batch, where the batch size is 1 to 8, and then it will use the stochastic gradient descent to update the W. Okay, it's not it's using the mini batch gradient descent to update the W. It's not a stochastic gradient descent. So in other words, even you see SGDM here, which is referred to stochastic gradient descent, but in Matlab, what is the meaning by SGDM? Is actually a mini batch. So like I mentioned before in the previous lecture, mini batch gradient descent is very common in which will be used in CNN. Okay, when you do the training option, if you select the SGDM and you set, even without setting the mini batch size, by default it's equal to 1 to 8, is actually a mini batch gradient descent. It's not stochastic gradient descent anymore, because if you want to, let's say you want to apply a stochastic gradient descent, then you need to set this one equal to 1. Okay, but okay, then you put here, that is called stochastic gradient descent. But because you are already set the mini batch size, which 1 to 8 by default, because you don't mention here, and by default Matlab will assume mini batch size equals to 1 to 8, it become a mini batch gradient descent. Okay, so I think you can also convert this into batch gradient descent. If you put this one, the size is similar to the size of your sample's training size to 7,500, so it become a batch gradient descent. So means that, but normally they will use a mini batch gradient descent. Okay, so the rest is, yeah, this is a learning rate, initial learning rate, and then this one is just for display the progress of the training, and then this one is the frequency of how much how many iteration, or how many iteration how frequent you validate your data. So means that if you set at 30, means that after 30 iteration it will validate the performance. So meaning that after 30, then we go next during the progress of training, and until 60 iteration, it will again check the validation loss or validation accuracy. So that's how they check before the system stop if the overfitting happen. So means that iteration number 1 you don't check, iteration number 2 you don't check, up until iteration number 3 you check one, and then iteration number 60 you check another one. So we don't check every time to apply that stopping criteria when the to make sure that to avoid the overfitting. Okay, so that is meaning by this one. And as you can see here, validation data is your validation data here. So this is your validation data, which is IMDS validation, which is this one. So you already declare my validation data is this one. Okay, this is option. So let me execute this one. Okay, nothing happened because just a setting. Okay, this is the one that this is single line is for the purpose of to executing the training operation. So train the network, and then the input is this is the training data, this is your architecture, and this is the option that you declare here. So you can see that the question is where actually the validation data, because validation data you declare in this argument. So where is actually validation data? Because this is training data, this is your architectures, your layers CNN architectures. So this is training option. So where actually the validation data inside this process? The answer is it's include in this option, because in the option you already mentioned that validation data is equal to our IMDS validation with this one. So and you will check you will do the validation for each 330 iteration. Okay, now we execute this one. Okay, it will take you some time to execute this one.